instructors, Ana. And Ana will be sharing her experience as a woman in STEM along with a live data demo. To start things off, our agenda here. I'd like to give you a quick overview of our programs and everything that we offer, and then I will hand it off to Ana, who will lead us through our discussion, and then we'll leave some time at the end for questions. Just a couple of housekeeping items. Today's session is scheduled to last 1 hour, including our Q&A. All participants are muted to enable speakers to answer as many questions as possible. All questions should be submitted in the Q&A box. We do have a moderator, Taylor, in there who will be answering some questions in the Q&A box. And then we will also have the chat box open that will be used for general announcements and resources. So please avoid using the chat box to ask questions for the panelists. We want to make sure that we are able to answer as many questions live as possible and we don't miss anything. You're also welcome to email us admissions@thedataincubator.com if you have questions you'd like to ask outside of this session, or perhaps we don't get to your question. And this session is being recorded and it will be sent to all registered attendees approximately 72 business hours after we conclude the session today. So we're going to start things off with our instructor intro here. So I will pass to Ana.
Thank you, Sierra. Like Sierra said, my name is Ana. My background is actually physics, and I meandered from physics into data science, which I'll talk about more in a moment. And I'm now one of the data instructors at Pragmatic. So I'm looking forward to the demo today. And yeah, I'll tell you a little bit more about my journey as well after Sierra tells you more about our programs.
Thanks, Ana. So a little bit more about our programs. The Data Incubator focuses on training people to become data scientists and data engineers. We get asked quite a bit, why is that important? Well, it's really because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a variety of industries, ranging from tech, retail, healthcare, many more. Every company has data and wants to use that data to drive value for them. So we know there are a lot of other data-focused programs out there. So I'm sure you're wondering what we do at the Data Incubator that is a bit different. Well, what we found when you look at training is there's usually two types of training. One being fast-paced and efficient, and the second being slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. On-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So what we've done at the Data Incubator is we've taken all of these aspects and combined them together to find a great middle ground for training. Our programs are fast-paced, but you'll also walk out of the program knowing a lot about data science and data engineering, but most importantly, it's based in the real business world. So you'll have the same applications with a deeper understanding that you would get from university. And then all of our instructors are PhD and master's holders, and many of them have completed this program themselves, so they know how to provide that in-depth training that you're looking for. And for our winter 2023 cohort, we'll be offering 3 data-focused programs. We're offering our successful full-time data science program and a more flexible version of that with our part-time data science program. And then we're also offering our full-time data engineering program. So a little bit about our programs. All of our programs are very intense. They are built around hands-on data-focused curriculums. And we offer these both full-time and part-time for our data science program, but all of our programs are packed with a lot of information and tools. Each week, we'll focus on a different data tool or approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. And so in each program, students will work on mini projects that focus on the data tools that you're studying. Additionally, our programs are very collaborative. We want our students not only to work with their colleagues and instructors, but also have an opportunity to network and connect with our hiring partners. And we also have career coaches that help you succeed in your data-focused careers as well. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have an opportunity to work with a top resume writing company to get a polished resume and cover letter. And then every student in our program is provided a Jupyter server for the duration of the course. So students can follow along in lecture and see and edit raw code as it's being run. And you'll also receive immediate feedback via our interactive grader. This is just a quick overview for our data science program. The full-time data science program lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week working on assignments. And then again, this is just a quick overview of the curriculum broken down by week. If you'd like a more detailed curriculum overview, please email us. We're happy to go over the different modules that you'll cover in the program. For our part-time data science program, it lasts for 20 weeks with classes held on Tuesdays and Thursdays from 7 p.m. to 9:30 p.m. Eastern. And you can expect to spend about 10 hours per week outside of class working on assignments, and you'll also have office hours available each week. You'll receive the same excellent curriculum and training as our full-time program, but at a slower pace. And the sessions are still live and instructor-led, so you're able to interact with your instructors and peers and ask questions. And then similar to our full-time data science program, our full-time data engineering program also lasts for 8 weeks with classes held daily, and you can expect to spend about 40 hours per week outside of class working on your assignments. So we also, I think we skipped ahead. I will now pass to Ana before we go into our different scholarships options, and I will join back on at the end to help answer any questions.
Thanks, Sierra. As I mentioned, I am going to share a little bit about my journey into data science before we jump into today's demo. So maybe before I share my screen to start going through the Jupyter notebook that I prepared for today, which the link to which you should also get. So if you want to follow along, you can do that when we get started. But before we do that, I thought I'd tell you a little bit about how I got into science, what my experience as a woman in data science has been. Basically, the way that I started my journey is I studied physics, and I was really into it and I really liked it, which is why I decided to go and do a PhD in physics. And after that, I obtained a postdoctoral fellowship at the Rockefeller University. And that was actually like an independent fellowship. So Rockefeller University has a Center for Studies in Physics and Biology, which is like a very interdisciplinary center where basically it was an independent position, so I could work on whatever I wanted. So I liked that, and I liked that it was kind of very interdisciplinary. And essentially, as I was doing that, I started to feel more and more that I would maybe like to work on things more applied, things more in the real world, and maybe not so academic. So that kind of started this journey for me to start thinking beyond just physics, and data science just seemed very appealing and a very natural step for me, given my background. And so I applied for Data Incubator's fellowship. So I went through the program myself, which is why I can highly recommend it firsthand. Yeah, and I just basically knew right away that that was the right choice, and kind of that data science is kind of the right fit for me. I ended up then working at the Data Incubator, which is where I still am. My experience has been fantastic at the Data Incubator, but I also have to say actually before. So I think this context of a woman in data science or being a minority in your workplace certainly extends back. In physics, it was certainly the case already from starting from my undergrad, and then maybe even more severe in graduate school, that it was, I was in a heavy, tiny minority. I have to say that my experiences were, for the most part, very good. I was very lucky, I think. I think that my experience going through it, the fact that it was good does not testify to that we don't have a problem. There is a big problem. Women are severely underrepresented in STEM in general and in data science as an extension. So I would say that one of the main things that I missed were just more female role models and female mentorship, and just more diverse environment. Again, I should say that I was lucky with having very good mentors nevertheless, and I've had very good experiences. And now working in data science, the team is just wonderful. But I think that's very much, and I feel that I have all the opportunities that my male colleagues have. We are a small team and it's just a very nice environment. But I think this is really, again, not necessarily a testament to how it is everywhere. So I think in the industry itself, like I said, the problem is big. Women are severely underrepresented. Google and Facebook, for example, report that in their AI research teams, there's something between like 10 and 15% of people are women. I recently ran into this fact, which shocked me entirely. I read that UK's Alan Turing Institute made this survey or research where they found that about 8% of active users on Stack Overflow are women. I was seriously shocked. So the problem is there. And I would say that in data science in particular, the diversity is very important. We know that data science is a field prone to bias. How we collect the data, what kind of data we use, how we analyze the data, how we prepare it, how we do our machine learning and everything else. Can be very biased, and a potential source of bias in many data sets is that, you know, if you have 80% of the team are men, that's just a bias you could have there. And I think that serves no one. So I think it's hopefully is or should be kind of everyone's goal to fix that. I do think that, of course, the problem goes deep. It's obviously just as a kind of extension of the fact that there's this kind of imbalance in how many women there are in STEM-related fields or subjects. So I think that's just globally like that. And certainly, I think that root should be where differences should be made. But all that said, I also don't want to be too grim. Again, I've had a wonderful experience. I hope to kind of encourage more women to obviously go into STEM or data science specifically, despite it being kind of as imbalanced as it is. Again, my experience has been good, and I think only more women in the field can, you know, that's what we need. So I think that's kind of what I would want to convey also, is that it can be a very nice experience. One thing that I would say is that maybe what we can do is, for anyone who is looking for maybe a woman in the field or wanting to enter the field, I would like to highlight that there are many data science communities just in general, and also data science communities for women specifically. So if you, for example, just Google it in your town, wherever you live, or in your country. I know that I used to live in New York. Now I'm in Berlin, Germany. In both cases, there's meetups, there's data science communities, and a lot of these communities will then also have mentorship programs or other ways of how you can kind of get some encouragement, support, help, and all of that. All right, maybe enough about that. Why don't let me start sharing my screen, and we can jump into what we prepared for you today. So if you have been to any of our previous data science demos, you will see that we have talked about all sorts of things, but I don't think we've ever talked about optimization before. So I thought I would bring up this topic for today's webinar. In data science, you do all sorts of things, from data cleaning to visualizations, machine learning maybe. But sometimes you also need to solve optimization problems. And what that means essentially is that you have a problem that may be framed like so. You have some quantity, something that you either want to maximize or minimize. let's say if it's revenue, you probably want to maximize it. If it's some sort of cost or error rate or something like this, you may want to minimize it. And most often in the real world, that's going to be subject to some constraint. You are going to have some form of constraints about maybe how much resources you have, how much time you have, or other things that need to kind of are restricted. And when you want to find the solution, essentially, of what should we do, what should be the strategy given what we're trying to maximize or minimize, this is an optimization problem. Sometimes this can be solved analytically. I'm going to today focus on numeric tools of how you can do optimization in Python. And one of the places that kind of hosts useful tools to do that in Python is the SciPy library. SciPy is one of these kind of core Python libraries that form this Python ecosystem of libraries, together with probably NumPy, Pandas, scikit-learn, others that you may have heard as well. So it contains many different sort of tools, distributions, tools for finding roots of functions, as well as for optimization. So that's what we're going to do today. I'm going to show you 3 different examples where we're going to have to use the tools slightly differently depending on what our problem is. And the first one is going to be simple minimization. That is, for example, when I have an optimization problem without constraints. So in this case, let's say that I'm going to start very simple here, extremely simple example of, let's say that I can describe our profit like so, yeah, where, for example, X is the amount of time or kind of effort that one can put in, and P is going to be our profit. Now, X is something that we kind of are trying to fix. That's what we're kind of trying to tweak to maximize P. So if I can write down, in this case, P, my profit, what I'm trying to maximize in an equation like this, we would call essentially this P an objective, just a little bit of lingo. And this X is our decision variable. So this is something that I tweak, in our case, the amount of hours worked, for example, to maximize profit. If we were to plot this very simple function, it looks like this. So it clearly has some maximum somewhere. By the way, this is a very simple function. You might think to yourself, I will just take a derivative of this and find the root. Yeah, and that's going to, of course, as you know, probably, right, if you have some function. Where's my pen? If you have some, let's not make it red. If you have some function, yeah, whatever it may be, and you're trying to find, in this case, let's say the maximum, if you just, and that's your function, is a function of some, in our case, decision variable X, I could just take the derivative of X, of F with respect to X, and find the 0, so the root, and that would, at the X at which that's 0, that would be my optimum. That's very much what you would do here because it's such a simple function. But still, let me show you how you would do this numerically with SciPy. So SciPy has a minimize routine or function that's going to help us do exactly this. So I'm going to import from SciPy's optimize module the minimize, and then all I need to do is I need to plug in the function that we would like to minimize in this case. So it's implemented as it's going to find the minimum. Wait, but I'm trying to find the maximum. So that's what we do here with this trick, where we basically take the negative of the profit. And that's indeed what we want to minimize because we want to maximize profit. Yeah. So just a little trick, because there's only a minimize function in there because it's so easy to flip functions with the minus in front. Good. So basically, right, if I have some, what's going to be my profit if I work for 5 hours, it's that, and negative that, right, is going to be exactly what we get here. So minimizing that just means I have to plug in this function that we are minimizing. And I also need to specify a kind of where we're going to start, if you will. So I have to provide some initial guess, rough guess of where I think this maximum may be. And then the minimize method is going to optimize this function and find the minimum. And if I run this, I indeed see that happen. So we found that it terminated successfully. It found the minimum to be at this value of x, and this is the function value. So our profit, well, the negative of the profit. So this is then our profit in the optimum, so in the maximum. So that's the maximum profit we can make, and we'll make it if we work 7.5 hours, given that curve we had. So this was very simple optimization because I just had a function that I was trying to find, in this case, the maximum of, and with this minus trick, the minimum of. It's much more common that you are going to have some constraints though. So when you do optimization in SciPy, you can do that as well. So we can add constraints to the problem. So let's, for example, still stick to what's called linear programming. That means that what I'm trying to maximize or minimize is a linear combination of my variables. Yeah, so in that case, that means I'm still talking about a linear problem. And also my constraints are linear. Yeah, so what we mean by linear is, for example, this is a linear function of x, y, and z. Yeah, this on the other hand is not linear in x and y, right? We have a mixed term here. Or if I had a cosine of x or y squared or square root of z or anything that's nonlinear, then it would be nonlinear. But I'm sticking to a linear examples. So let's kind of have this very simple example here. So we are gonna have this factory example. Let's say that we have a factory that produces two kinds of products. We're gonna call them P1 is the first product we create, and P2 is the second product. And we know how much profit we make if we sell 1 pound of the P1 profit or 1 pound of P2. Selling a pound of P1 gives us 5 units of profit. Selling a pound of P2 gives us 8 units of profit. Okay, good. Now, I also know that if I want to make a pound of P1, I need to use 2 units of my resources. Whereas if I want to make a pound of P2, I need 3 units of my resources. Yeah, of course, I want to maximize profit. But at the same time, I know that my constraints are that I'm limited to, I can only make 4 pounds of either product, both products together. So in total, only 4 pounds. And I only have 100 units of resources to spare. So how many of which product should I make to maximize profit, given these constraints, given what I know about for how much I get to sell them and how much raw resources I need for each product. Yep. So this is a simple linear programming problem because, as you'll see when we write out the equations, they're all linear. So we do need to be clear in understanding what are our decision variables. In our case, those are how much of P1 do I make? How much of P2 do I make? We're going to denote those as P1 and P2. So P1 is the number of pounds of P1 I'll make. P2 is the number of pounds of P2 I'll make. What are we seeking to maximize? We want to maximize our profit. And what are our constraints? So let's write all of that down. We want to maximize profit. And I know that for every pound of P1, I make 5 units of profit. For every pound of P2, I make 8 units of profits. That was in the instructions. So therefore, that's my profit. And I want this to be maximal. So what should be P1? What should be P2 in order for this to be maximal? That's what I want to find out. Now I have some constraints. I know that I can only make up to 40 units. And I also know that I have 100 units is in 40 pounds, sorry. And I know that I have only 100 units of resources. And P1 uses 2 and P2 uses 3 units of resources. So if you write down your objective function like this and your constraints like this, in this case, you can notice that it's all linear. Yeah, P1, P2 are linear here. They're all linear. Therefore, we have a linear programming problem. And the way that we can solve this is using linprog from SciPy. By the way, in this case, we also know that we cannot make a negative number of P1 or P2. So they should all both be positive, which means we also have this constraint. So if you want to use linprog from SciPy's optimize, that's going to be a optimization problem that is linear. So it means, as I said, all of my constraints are linear and my objective function is linear. And what we need to do when you're using linprog, and actually we here link to the documentation itself. Documentation is very good from SciPy. Feel free to check it out. So here you see that it explains to you, if we look at kind of what we are dealing with, this is the type of problem that we have, right? In our case, we have some combination of P1 and P2, and then some sort of restrictions on the other side of the inequality. Yeah, so we're kind of in this regime. So we need to put the AUB and the BUB into is what we need to specify. So that's exactly what we do here. And as you are doing that, just make sure that when you write down your objective function and your constraints, you kind of check in the documentation what A is and what B is. So in our case here, A is, here's a 1 and a 1 because I have a 1 in front of P1 here and 1 in front of P2 here. And then I have a 2 and a 3 because I have a 2 in front of P1 and 3 in front of P2. Yeah. B is what's on the other side of my inequality, in this case, 40 and 100. Yeah. And then here, C comes from this equation. So what we are trying to optimize. Yeah. So this is what you could see here. But again, same as when we were doing minimize, this is minimization. The way that this is implemented in SciPy is that it's minimizing. And therefore, but I'm trying to optimize. I'll just flip the sign. So here, because we're trying to maximize that, well, if I put a -5 here and a -8, then I'm minimizing it. Therefore, I'll find maximum profit. We can also specify the bounds, and this is where I want them to be positive. Therefore, the lower bound is 0, the upper bound is infinity. And then we just plug all of that into linprog in SciPy. Yeah? And if we do this, it's going to solve the problem for us. We can check the result here. We can check the message on the result. It says that the optimization terminated successfully. And as it does that, this object called res here also, of course, contains, okay, so what is the best value for P1 and P2? Those are going to be in the .x attribute. So if you look at a res, it's always going to be called x, even though we are referring to that as P1 and P2. But my P1 and P2 are these two. Yeah. So if you take out the 0th element of that, is going to be, in our case, from the way we wrote the equations, our first, so P1, and the second one is P2. So if we round up the two results to 3 decimals, you'll see that I shouldn't make any of the product P1. I should only make 33.3 pounds of P2. Yeah. And this is actually not uncommon in linear programming problems, that you are basically pushed to the side of your domain, if you will. Well, where in a way, maybe you even have that intuition. Yeah, I should probably just make that product which has a higher profit. Why would I even bother making any of the lower profit product? Yeah. So in this particular example, we also have a little visualization here that kind of demonstrates that. So if we here take the two constraints we had, if you remember, was that I can make 40 pounds in total of both of them. Well, how about if I break that constraint? That would mean that, oh, I can make, what if I made more than 40? That would be in this entire red region. That means I cannot have a P1 and P2 such that I'm in the red region, because that means I made more than 40 pounds and I can't do that. And similarly, breaking the other constraint that we had about the number of unit raw resources we had is this blue region here. In here, we're breaking the constraint. That means that the solution has to be here. Yeah, somewhere in this region below. And if we look at the objective function, we're essentially looking for the profit in here that's going to be maximized. And it's, of course, where we just don't make any of the lower margin product, but we only make P2 in this case. All right. So that was linear programming problems, which meant that our objective function was linear and our constraints were linear. It's even more common, I guess, that you would have nonlinear problems. So that would mean nonlinear optimization, where either your constraint or your objective function is not a linear function. And in that case, what that means is that we need to do nonlinear optimization. Now, the same function we were using, so the minimize in SciPy, will be able to solve this for us just as well. We'll just have to do a couple additional things, but for that example, let's look at this sort of problem. Let's imagine that you want to build a fence. So that means something like this. I want to build a fence. This is supposed to be rectangular. I can do better. I mean, that's a little bit better. If this is X long and this is Y tall, if you will, or long, that's my fence. And I know that it costs me different amounts to build in vertical and in horizontal direction. So let's imagine that I pay 4 per unit of building in the vertical direction and 7 per unit in the horizontal. So if that's the case, then my cost of building is going to be 4 times 2 times Y. Yeah, I have 2 Y sides and 2 X sides, where per unit it costs me 7 in that direction. So this is my total cost of how much it's going to cost me to build this fence. But I also have a constraint. This is linear so far, but my constraint is not. My constraint is going to be that, well, I want to make sure that I enclose at least 100 units of area. So that means that X times Y, that's the area in my my fence, is at least 100. So now the question is, I want to, of course, minimize my cost, but I have to enclose at least 100 units of area. So should I build a fence like this? Should I build a fence like that? Should I build a fence like this? What should I build? Well, I know that's going to have to be such that the area is at least 100, but then I still may build something like this or something elongated like that. What the dimensions exactly minimize my cost while I have enclosed at least 100 units of area? So that's the question. And we're going to solve this again with SciPy. And the way that we can do that is we basically have to rewrite our problem like so. Yeah. So in SciPy, when we are going to put this, as you'll see in minimize, we're going to have to reframe our problem as if we are dealing with an inequality like this. Now, in our case, this is how we wrote the constraint to start with. So if we rewrite it in this form, it means we get this, right? So this means that my f of x and y, this constraint function inequality, this f of x and y is this. So that's my function. Yeah. So if my f of x and y are x, y minus 100, notice that this is a function of both x and y, so 2 variables, and it's not linear. And now what we need to do in order to use minimize, as you'll see in a moment, is I am going to have to help it a little bit and provide it with the derivatives of this f of x and y. Now, because it's a function of 2 variables, I actually can either have a derivative with respect to x or derivative with respect to y. And that's exactly what the Jacobian is. Yeah. So we're going to do a partial derivative of this with respect to x. So that means I'm going to take a derivative with respect to x, which is, well, that means that y is here like a constant. Yeah. X is my variable that I'm taking this derivative with respect to, and this is also a constant. So this is going to be derivative of this is 0, derivative of this is y. Y acts as a constant when I'm doing a partial derivative of f with respect to y, x. And when I do f with respect to y partial derivative, well, then x acts as a constant, and that's all that I have. So as we rewrite this into kind of basically a Jacobian matrix, as you'll see here. That's what this y is. This is the derivative of this function with respect to x, and this is the derivative, and I'm trying to highlight just x, and this is a derivative of this function with respect to y. And now that we have this, let me show you how we can put this into essentially this same minimize we've been using before at the beginning of the notebook. So what we can do is we just say minimize. Okay, what are we trying to minimize? Well, we want to minimize our cost. What is our cost? We made it into a function. Remember, that is 7 times 2 times my x plus 4 times 2 times my y. Now we are going to have this single variable here, xy, which just has 2 dimensions. So the 0th element of that is x. The first element of that is y. Yeah. And if I write it like so, then that's what I'm minimizing. So that's my cost. I also need to specify what are my initial guesses. What is my guess for what is the best x? Maybe it's 1. What's the best y? Maybe it's also 1. So this is where basically your optimization algorithm is going to start. That's the initial kind of starting point. We specify the solver, so the method that's going to be used. This is something you can tweak and play with depending on the type of problem you have. And then this is where the constraints come in. And this is where this work that we've been doing up here, this is where this comes into play. This has to be a dictionary like so, where we specify that we are dealing with an inequality, because this is not equality, but you see that we have an inequality here. Then we specify what is the function that you're trying to minimize. I'm trying to minimize a function which is x times y minus 100. That's what this is. Yeah. And then what is our Jacobian? Well, that's what we computed here, right? So that means this function, the derivative of this function with respect to x, the first variable, and then y, which is that. So that's what we have in here. And when we plug all of this into our minimize, we get, of course, the result. And that tells us that we are going to be right at the limit of the area because we want to minimize costs. So it's not surprising, right, that if I want to minimize costs and I want area at least 100, that I'm not going to build bigger than 100, because probably I can minimize the cost by really being at the border of 100. And my x should be this, my y should be this. So basically, the name of the game here is just that you want to make sure that you are familiar with SciPy's optimization, and so that you just rewrite your problem in the form that you then plug it in, so that basically it plays nice with what, in this case, minimize expects from you. I think I have time for just one more quick example. Let's imagine that we want to invest in the stock market. Let's imagine that what I want to do is I want to, of course, maximize my gain. And I can model that as this C here. And the way that I sort of gain something is by, if I bought SI of stock I, if I multiply that with kind of the expected return on that particular stock, multiplying the expected return with the amount of that stock, which is SI that I have, summing that up across all the different stocks that I have, that's kind of my overall return, if you will. But there's also a cost, and that is the volatility of the stocks. So let's say that we're going to model that as, if I know the variance of the price, that can be kind of a measure of the risk involved with having that stock. So if this is then basically the volatility or the variance of any individual stock, this is how we model the risk. And that's what I have a sort of weighted here with this gamma parameter. And that's negative, as in, yep, I want as high of a return, while I also want to have as low of a risk here. And let's imagine that we also have some V total, we're calling it here. So basically just some overall market variance, overall a variance that is kind of the volatility of the market overall that we're going to add to this as well. We could go into more details here about the kind of financial modeling, but let's imagine that this is our equation of what I want to maximize. I want to maximize this. That will mean I got a lot of returns while paying little risk, if possible. So the question will be, let's imagine that we have 3 stocks. I have 3 of them. Now, how much should I invest in stock S1? How much should I invest in stock S2? How much should I invest in stock S3, where I know the expected return for each of them, I know the volatility of each of them, and I know the overall volatility of the market. But I have a constraint, and my constraint is that I have 10K to spare. I can only buy 10K of stocks. Therefore, these 3 numbers have to be less or equal to 10. So if this is my problem, yeah, with respect to this particular constraint, again, not linear. Yeah, you see all these non-linearities here. Therefore, we're going to use the same approach as in the previous example. I have to rewrite my constraint in the f of x, or in this case, f of S1, S2, S3, is greater or smaller than 0. So I have to bring this 10 over here and rewrite our equation that we're trying to, that's our constraint, in the way that SciPy expects. And now that I have this, all that I need to do is remember the Jacobian. I'm going to have to compute the derivative of this with respect to S1, which is -1, right? The derivative of this with respect to S2 is also -1. And the derivative with this with respect to S3 is also -1. So I'll be using that. Let's just plug all of this in. Same as before, what am I trying to minimize? Well, my reward function, which is essentially just putting into Python what we wrote here, all of this. I have a positive term, which is my rewards multiplied with my stocks values. And I have a risk, which is every volatility or variance of every stock times the stock squared. Yeah. Plus, I'm also adding the total kind of this overall market volatility. And that is my total reward. And that's what I want to maximize. So that because of my minimize, I again have to do this minus trick there. So that's what I'm minimizing. Good. What are my initial guesses? Well, I'm going to say that, for example, I'll start with 3, 3, 3, as in maybe I should buy 3 of S1, 3 of S2, 3 of S3. That's just an initial guess that you have to plug into minimize. We again pick the same method as we did before. And for our constraints, we are again, remember this dictionary where we specify it's an inequality because I don't have an equals here, but I have an inequality. What is my function? My function is 10 minus sum of all the s's. What is my Jacobian? That's the taking this function and then doing a partial derivative with respect to S1, with respect to S2, with respect to S3. And that's what we have here, -1, -1, -1. But if we run this, we know how to beat the stock market. That's how much of S1 we should buy. That's how much of S2. That's how much of S3. And that will give us a final reward of 3.86. And looking at the time, I think I'll stop here. You have the link to this notebook. If you are into analytically solving problems, or if you're curious how to do this other than numerically, there's a little section at the end about Lagrange multipliers and things like that. So I'll stop here. I'll pass it over back to Sierra.
Thank you so much, Ana. And Ana is staying on. So if you have questions, please put those in the Q&A. We will be opening up our Q&A very soon. But I want to give a little bit more information about our programs and our different scholarship offerings. We get asked pretty frequently if we offer scholarships to any of our programs, and the answer is yes, we do. We offer scholarships to all of our programs. We admit 2 types of students into our data science and data engineering programs. Fellows are offered tuition-free scholarship spots for our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network and may maintain their current employment. Scholars still have the same access to curriculum, resources, and tools as their fellow students, and full tuition scholarships are not offered for our part-time program. We do also offer partial scholarships. So we are very excited to continue to offer our Women of Excellence in STEM scholarship and our Equity, Diversity, and Data scholarship for our winter 2023 cohort. These scholarships aim to help remove barriers and provide opportunities for women, veterans, LGBTQIA+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. Our scholarship applications are open now. So if you're planning on applying for the program, we do encourage you to also complete that scholarship application before the challenge deadline, which we'll go over soon. And you can visit thedataincubatorscom/programs and scholarships to review qualifications and to apply today. A big component of our program that we really pride ourselves on is helping our students to not only grasp data concepts, but also getting you a job in your field. Our engineering program is still pretty new, so we don't have data there just yet. But for our data science fellowship program, 97% of our students that go through our program are currently employed outside of academia, and 88% are employed within 6 months of completing the program. And that's really the challenge, not only content, but being able to transition into a data science or data engineering role. And that's where our program stands out because we help you to do both. You may be wondering where our graduates are now, where are they working, what are they doing? Well, we evaluate our placement rates on a 6-month basis again, so data is not available for our engineering program just yet, but we can give you an idea based on our placements for our data science program. Our graduates are working in over 55 different industries, and some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And some of the typical job titles we see are data scientists, data analysts, research scientists, and many more. The titles and roles vary depending on the company and industry, but this is just to give you an idea of some of the roles we've placed in the past. Again, I know we mentioned that we don't have data for our engineering program just yet, but you'll see we have placed students in data engineering roles in the past, and most of our hiring partners are also currently looking for data engineers, and we've seen that demand for this role has grown about 40% year over year. And we've also seen that our graduates are earning about 16% more than industry standard, which is very exciting to see. And then here is a short list of our data science hiring partners. As I mentioned earlier, many of these companies are also hiring for data engineering roles as well. And then in addition to our different scholarships options, we also offer financial assistance to all of our programs. So we've partnered with Leaf to provide an income sharing agreement. It's great. You can participate in our program with just a deposit down, and you won't be required to make any payments until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 options: deferred repayment, interest-only repayment, and immediate repayment options. We also have some new financing options coming to us through Leaf, so you'll see an announcement about those very soon. And then lastly, for many of our part-time programs, companies are willing to sponsor or pay for their employees to go through the program. It's a win-win. You get to learn great stuff in the evening and be able to apply that to your job during the day. So it's an opportunity to participate in the program with as little as $0, depending on what your employer is willing to sponsor. So if this is something that you think your company would be interested in or you would like to present to them, we do have a letter we can provide you that'll help you lay out the program and all of the benefits of attending. So where are we right now? Well, we run multiple cohorts a year, and our fall cohort is about halfway through their program, but the application for our winter 2023 cohorts is now open. The winter full-time cohorts will run from January 9th to March 3rd, again for full-time, and part-time will run January 9th through May 26th. And the full-time cohorts are 8 weeks long and part-time are 20 weeks long. We ask that you submit your application by October 28th for our regular admissions deadline, and then you'll have 72 hours to complete the coding challenge from the time that you open it, and the final challenge deadline is October 31st. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues because we're unable to reopen the application after that deadline. So if you are interested in the program, which I hope that you are, you can go to thedataincubatorscom/apply to submit your application. And if you have questions about your specific situation, this presentation, or just going through the application process, please reach out to us at admissions@thedataincubatorscom and we'd be happy to answer your questions. So at this point, I'll open up our Q&A again. If you have questions about the program or for Ana, I'll be happy to answer those now. So let's see, there's a couple questions I want to pull from. I'll defer to you on it. It says, what would you say is the difference between a data scientist and an AI ML engineer? And is what you learn the same, but applications different?
I would say that data scientist is a broader term, if you will, and AI ML engineer is a bit more specific. What you end up doing when your role is called data scientist really varies still. So it may be that you do machine learning nevertheless. But in a bigger organizations, bigger companies, usually if they have a specific role for an ML engineer, like an engineer, machine learning engineer, that then usually means that data scientists are going to do more of the interpreting stuff, analyzing the data, collecting, cleaning the data, and sort of machine learning engineers will focus more on the machine learning part. So it kind of still varies, but I would say, yeah, machine learning engineer is just a bit more narrow and a bit more just about machine learning.
All right, another question here. It says, hi, Ana, did you ever consider learning data science by yourself other than taking a data science course? And how is your certificate from the data science school, like the Data Incubator, helped you to get your current job?
I would say that, yes, I have considered learning things on my own. And I think as a data scientist, you learn all the time just by using tools. You learn on your own, even when you are in a guided program, like let's say, or a mentored program like the Data Incubator. You always learn a bit on the side on your own as well. My biggest sort of, I would say, comparison between if I had not taken the Data Incubator Fellowship and if I did is the amount of time it takes you if you do it yourself. So if you don't have any guidance, comparing to how much you're going to learn if you take, let's say, the full-time fellowship, in 2 months, you're going to learn so much. I remember when I was done with the program, I felt like, oh my God, if I could spend every 2 months of my life like this, I would know everything. Like, this is just like, I didn't know I could learn this much in 2 months. I don't know that's possible if you are doing that on your own. You just are never, you can't, like, you know, we've prepared the projects for you that you're going to work on. You have structured lectures, you have a structured curriculum, and I think it just takes way longer to do it on your own, and you have less support, not to mention the support in job search. So I would say that, you know, you also get that, which you don't have if you do this on your own. Yeah.
Another question, are there any salary differences between male and female data scientists as far as you know?
I have to knock on wood, I have good experience with that as well, but I know that there are differences. Yes, I think that the pay gap extends to data science very much so as well. So I think it's important to have the world change, but also just if you are a woman data scientist to ask for raises. I think that's one of the bigger differences, that men tend to ask for raises before women do. And I don't think this is on us girls. I don't think this is a female problem and we have to solve it. But before the society actually changes, I encourage you to yeah, be more confident if you are a woman and if you're a woman in data science. But unfortunately, yes, my answer is I think there are salary differences.
Another question here. So this is about our finance options. Any plans on offering financial support for non-US residents? We also need it bad. So for our different finance options like Leaf and Ascent, for Leaf, you're not required to be US based. It does require you to have a US Social Security number. So if you have a visa type that grants you that, you're able to apply. With Ascent as well, if you're not a US resident, if you have a US resident that could co-sign for you on the loan, then you're still able to apply for those. And then if not, if you're paying directly, we do offer a variety of discounts as well. So if you secure a loan from another institute or something local to you, that counts as direct payment on our end. So you're able to receive that cash pay discount. All right, any other questions? I do see one more question about if this session is recorded. So it is recorded. It will be sent out to all registered attendees. So the email that you registered with, it will go to that email. It takes a couple of days to process, so keep an eye out for it. It is also available on our YouTube channel. We stream all of these live. So if you're just wanting to watch it right away, you're able to go onto our YouTube channel to watch it, or it'll also come to you via email.
Sarah, one more come through the chat. It says, does income sharing program accumulate to more than the tuition fee paid at once?
So it can. So that's part of the income sharing agreement. It's based off of your annual salary, and you'll pay 16% of your annual salary until you either meet the minimum payment cap, so 12 monthly payments, or the max. So there's a kind of a range there depending on your salary. If you're making like just at 40,000, you might end up paying about 6,500 for the program. If you're making what our typical graduates are making in the over 120, 130,000, then you would pay the payment cap, but it really varies depending on your salary. And the challenge deadline is October 31st. Application deadline, October 28th. And challenge deadline is Monday, October 31st. So you get a little Halloween surprise. Any other questions? If you have them, please drop them in the Q&A. We have time for maybe one more.
We had one come through the chat that said, can STEM opt keep their status while doing this course?
That's definitely something that you would have to discuss with an immigration attorney. We do have a lot of students that are on OPT that go through our program. So we'll be able to talk a little bit more about that as you're going through the application process. But if you have someone in mind on the immigration side that you can discuss that with, we definitely recommend doing that. The deadline for the coding challenge hasn't passed. So the early admissions coding challenge deadline passed. But again, we run an early admissions and regular admissions cycle. So there's still time to apply. If you didn't get your challenge in by I think it was the 10th, you can still apply for regular admissions, which ends on the 31st. And then I see one more question here. So no plans yet on extending your financial assistance options for non-US residents that don't have a US Social Security number. So we don't have any plans to make any changes to our international finance options. We try to appeal to as many of our students as we can, but those requirements are in place with those different finance companies that we are partnered with. But again, if you do secure financing, maybe through a local bank or something, you are eligible for additional discounts. Okay, everyone. Well, thank you so much for your time today. If we missed your question, or if you have a question that you don't feel comfortable asking in a group setting, please email us at admissions@thedataincubator.com. We're more than happy to schedule a call with an enrollment counselor, talk about your different options as well. And thank you, Ana, so much for your time today. I know our students love to hear from our instructors, and I hope all of you have a great rest of your day.
Thanks, everyone.